We are honored to have Mr. Jean-Pierre Gualigno with us. Mr. Gualigno, he is honorary president of the Laser Technical Center. He is incoming president, elected president of the IULTCS. Starting from this Congress, he is taking on that. He is vice president of the ATC, Tanning Chemicals Industry. Thank you very much, Mr. Gualigno, for honoring us by gracing this occasion by your presence and also moderating this morning session. I leave the topics, details of the presenters to you to introduce to our participants. Thank you very much.
Good morning, everybody. Thank you so much, Professor McLennan, for the good words. I want to say hello to Geoff Holmes, who is now far away from us, but online. So we are going to work to moderate this session together. And I want to say a special hello to our president, Luis Zunio. Thank you, Luis, to wake up early to be with us. So, for this second day, we will start the presentation. The first presenter is Dr. Hansen Bertrand. So a brief CV. He's from Brazil and graduated in chemical engineering. He got a master in materials technology and industrial processes, PhD in chemical engineering. He's also professor of chemical engineering at the University of Vale Torrio dos Sinos and at the Ritter dos Reis University Center. Investigation lines involve water reuse, characterization, and treatment of liquid effluents in the leather industry. So I hope you are in line, sir. Yes, I can see you. Okay. So you can start your presentation. So if you don't mind, Geoff, I will monitor the presentation, and then if it's okay for you, you will be in charge of the question and answer. If you can do this by distance, let me know if it's okay for you.
Yeah,
okay,
I'll try
Geoff?
my best. Yeah, thank you very much. Yeah.
Okay, good. So first presentation.
So good morning, good afternoon, or good evening, depending on where each one is attending the Congress. I'm Everton Hansen. I'm currently a professor in chemical engineering course at Unicinos University. And at this Congress, I will present some result of the studies carried out during my doctorate at Federal University of Rio Grande do Sul. The study is titled Analysis of Post-Tanning Chemicals and Reduction of Pollution Load in Wastewater under the orientation of Dr. Marilis Guterres and Dr. Patrici Akin. Leather production uses a high amount of water and organic and inorganic chemicals such as the acidulants, vegetable and synthetic tannins, natural and synthetic oils, dyes, among other chemicals. And the literature indicates that approximately 130 different types of chemicals are used by the leather industry. And these chemicals are not completely retained by the leather, as the transfer of chemicals from the bath into the collagen structure is controlled by a mass transfer process. So as the chemicals bind to the leather structure, the concentration gradient decreases and mass transport also decreases. That's why there will always be a certain amount of these chemicals in the residual flows at the end of the process, which ends up being discarded along with the tannery's wastewater. Post-tanning raw wastewater have been extensively characterized, including physicochemical parameters such as chemical oxygen demand, biochemical oxygen demand, nitrogen solids, among other parameters, in addition to toxicity tests. However, Only a limited number of studies have evaluated the relationship of ladder chemicals and their pollution load on wastewater. So physicochemical and toxicological analysis of ladder chemicals, their relationship with pollution load of raw wastewater, and also the determination of the supply of ladder chemicals in processing flows still needs to be studied. Thus, this study aims to evaluate and reduce the impact of chemicals used in the post-staining process on the main quality parameters of the wastewater. So to conduct the methodology of this work, post-staining formulation was obtained from a tannery in Brazil that produces 750 adder per day. The formulation analyzed was the one that had the greatest application by the tannery at the time of the study. The ladder chemicals were analyzed individually at the concentration indicated in the formulation and characterized for pH, conductivity, turbidity, chemical oxygen demand, biochemical oxygen demand, total showdown nitrogen, ammoniacal nitrogen, chlorides, sulfates, hardness, and total dissolved solids. And the cytotoxicity of these chemicals was also evaluated. Cytotoxicity assays were performed using cells of the V79 lineage, which is commonly used for environmental studies. And these cells were exposed to a culture medium that was diluted in samples containing the chemicals. The cells were exposed for 24 hours for acute cytotoxicity, 6 hours for chronic cytotoxicity. And at the end of this period, 2 final tests were performed: the MTT assay, which assesses cell toxicity through mitochondrial functionality, and the SRB assay, which measures the total biomass surviving after the exposure period. After characterizing the ladder chemicals, tests were carried out to reduce the supply of chemicals, at first on a pilot scale, with a focus on reducing retaining agents and fat liquoring agents, as these were the chemicals used in higher quantities in the formulation. And the reduction in the offer of chemicals was of 26% based on tests that were carried out previously. The residual floats were characterized before and after the reduction in the supply of chemicals, evaluating pH, conductivity, and total dissolved solids. And the ladder produced on a pilot scale was also tested for the organoleptic parameters of softness, filling, grain, and impregnation. The adjustment in the supply of chemicals was also tested on an industrial scale using the same reduction percentage applied for pilot scale. The floats before and after reduction in chemical supply were tested for pH, conductivity, total dissolved solids, COD, BOD, and sulfate. And the ladder obtained was tested for tear resistance strength, color fastness to light, and color fastness to friction. Okay, so the results of the characterization of ladder chemicals are presented in table 1, and based on these results, the main findings of this characterization are summarized in the next slide. So the analysis of chemical groups provided information on how each group of ladder chemicals in the formulation contributes to the pollution load of the effluents. The acetylants showed high conductivity and total dissolved solids, and the neutralizing retainer showed the highest ammoniacal nitrogen pollution load. Retaining agents were the chemical group responsible for the highest inorganic pollution load, and these chemicals also showed low biodegradability. Fat liquoring agents were the chemical group responsible for the highest COD load, also showing low biodegradability. And the fixing agent and the acid dye showed high inorganic pollution load, and the dye also presented high total nitrogen. Cytotoxicity results are shown in figure 1. this graph shows the cell viability after the exposure period compared to a negative control. The negative control is a test done without the presence of chemicals. Therefore, 100% means 100% cell viability, and the lower the percentage observed in the graph, the greater is the toxicity. So results show that the synthetic tannins were more toxic than vegetable tannins. The vegetable tannins are shown in yellow bars with higher cell viability, and synthetic tannins are shown in yellow bars with lower cell viability. Also, fat lacquering agents were the chemical group with the highest cytotoxicity. They are shown in green bars with low cell viability, and the cytotoxicity of oils was related in this study to the use of surfactants to obtain these chemicals, since oils are applied in floats as aqueous emulsions, and the cytotoxicity of surfactants occurs due to the lysis, the break of the cell membrane of the organisms used in the tests. And the fungicide also showed acute and chronic cytotoxicity, which was expected due to the presence of substances such as chlorobenzene in its composition. Based on the results of the chemicals characterization, optimizations in the supply of leather chemicals were implemented to reduce the pollution load to be treated by the wastewater treatment plant. So regarding the results of the tests to reduce the supply of chemicals on a pilot scale, the analysis of residual floats are shown in table 2. The adjustment in chemical supply resulted in reduction in conductivity and total dissolved solids in the wastewater. The results of the analysis of the residual floats in industrial scale tests are shown in table 3, and also shows a reduction in the concentration of all parameters. There was a high exhaustion of the floats, especially in the residual float 2, which was the float that contained the highest supply of fat liquors in the formulation. This residual float showed up to 89.8% reduction in BOD, which is related to an improvement in the diffusion of oils, since the various post-staining chemicals are less concentrated together in the float. The organoleptic evaluation of the leather showed that softness, feeling, and grain had equal mean results before and after chemical reduction, and the visual analysis of impregnation showed superior results after the reduction in the supply of chemicals, which may be related to the lower concentration of other chemicals, which would compete in the diffusion of the resin into the leather. The physical mechanical quality requirements were met on the leather produced on the industrial scale for all the tested parameters. So at the end of this study, it was possible to verify that the leather chemicals used in the formulation represent relevant contribution to the organic and inorganic pollution load of raw wastewater. The results both on pilot and industrial scale show that it was possible to reduce the pollution load of the raw wastewater, maintaining the organoleptic properties of the leather and meeting the established physical-mechanical requirements. These results motivate efforts to reduce the environmental impacts of tanneries, as the extrapolation of the use of this technique in other tanneries can reduce the mass of leather chemicals used and the pollution load of these industries' wastewater. So this photo shows a part of the research team: Professor Marilis Guterres, Professor Patrici Akin, and me. These are the references used during the presentation, and that's it. Thank you very much for your attention.
Thank you very much, Dr. Everton Hansen. I've seen Marie-Louise Gutierrez on video, so I say hello to her, because we know each other for so many years. So thank you so much. You are right in time. The question we will answer at the end of the session. Thank you so much. Muito obrigado.
Thank you.
So now let's go to the second lecture. You have on your paper the name of Mr. Dietrich Tegmeyer, but in fact he's replaced by Mr. Martin Kleban from TFL. Mr. Kleban, are you here? Are you with us?
I'm on the screen. Can you hear me?
Yes.
Okay. Good to see you. Okay, so I don't have much information about your curriculum vitae. I just can say that you are, of course, from TFL at the head of the global head of HSEQ. Okay, so I'll let you start your presentation, please.
Okay.
Go ahead.
I'll try, if it works, that I get my screen on your screen. So my computer now says you should see a page with a TFL logo. Is that correct?
Yes, we can see that.
Okay,
very clear.
then let's go. After listening to so many technical and practical presentations through the last day, today I'm going to present something that is completely theoretical, or at least it looks completely theoretical, but I hope you'll recognize that it is very important for practical application as well. The European authorities in recent years have come forward with a program for greener and safer chemistry. And within that program, they are looking at a myriad of chemicals, and some of them are used in the leather manufacturing industry as well. And so the title of my presentation is Bisphenol and Glutaraldehyde: Will Old Chemicals Become a New Issue in Leather Manufacture? You may ask yourself, what is a bisphenol? And actually, it has no, or the substance itself in leather chemical is not known, or has not been known until a short time ago. The lead substance in this group is bisphenol A, you see to the left. It is a molecule that is composed of two phenol groups and a bridging component, which in the case of bisphenol A is acetone. That is where the A comes from. And this is a huge volume chemical that is used to manufacture various plastics for all kinds of applications, from buildings to the CD you put into your computer. That's all made a bisphenol A based plastic. The uses, as I said, high performance plastics, raw materials for various resins, and that's the most critical one, color developer in thermal papers. There already are a number of regulations around bisphenol A, and what is new now is that the authorities are looking at other bisphenol as well, like the bisphenol F, which in its own is a virtual substance, but as we found, it's the reaction product of two phenols with one formaldehyde. And those people who are familiar with synthetic tanning agents, they know raw material for those products is formaldehyde and phenol. And so the bisphenol F can be an impurity in synthetic tanning agents of the phenol type. And then we have something which the authorities call bisphenol F. We used to call it sulfone, because in that case, the bridging group is not a carbon, but a sulfur. It impacts a completely different chemistry to this type of chemicals, but nevertheless, it contains two phenols, and so the authorities like to put it into the same group. And that now is the monomer for the other group of synthetic tanning agents, those that have the higher light fastness properties than the phenol types. So basically, this is how we come into this discussion. None of those substances as it is used in leather, but they are or they can be raw materials for synthetic tanning agents. Bisphenol A, as you have seen from the structure, is a phenol, and it shows the typical acute and toxicity and corrosiveness for a phenol type substance. And recently it has been demonstrated that it is a low potency reprotoxin to mammals and to the environment, to fish. And it is believed that the mechanism for this effect might be endocrine. So the bisphenol A is working in the body like a hormone, and the most prominent one is like estrogen. So that is why there is an influence on the reprotoxicity. And some tests with other hormonal receptors indicate effects as well. To my knowledge, there is not a single case where such thing could be proven in a human being, but the animal test and the reagents test, they show some effect. And this is why the bisphenol A has been listed as an SVHC candidate under REACH, which imparts some needs for reporting and registration, and is normally the step to go into authorization. But the authorities have decided that authorization is not the best way to regulate bisphenol A, but instead they want to go by individual bans and restrictions. And so already in place is a ban against the use of bisphenol A for plastic bottles, especially if they are used for children food contact material. There is a REACH restriction against the use as a color developer in the thermoprint papers, and there is a restriction announced on BPA in consumer articles. And this restriction now not only covers BPA, it covers the similar substances as well. And this is the point where we come in, because the authorities have listed BPS and BPF as a similar substance. The intention of the restriction is to define a threshold for chemicals if they are used in Europe to manufacture leather, a threshold for the consumer articles that are imported into Europe. So the restriction will have an impact as well to tanneries that are working outside of Europe, because the leathers are impacted. And there should be a migration test method to make sure that if the concentration in the article is considered a little bit too high, that nothing exits the article. In original, the draft of the restriction should have been published 4 weeks ago, but the authorities have postponed it because there is quite some discussion around the scope. The first point is the question, will the BPS be in the scope, because the effects are substantially different from the rest of the bisphenols. There is a question that most bisphenols are not very well investigated, so will they apply BPA to all the others? And then there are some disclaimers about strictly controlled conditions under which the substances might be used. Anyhow, this discussion is ongoing. The finalization for the restriction is expected early 2023, not earlier, and then the implementation maybe in 2025. It's pretty clear that this restriction will have some impact on the leather production chain. And the thing that we need to do now, and this is for all the manufacturers of chemicals, everybody needs to be transparent on his chemicals in a way that the leather users get a clear picture which are the products that have or that may have some issues in the future, and which will be the impact on their supply chain, in a way that they can put their weight into the discussion to make this a workable restriction. In Europe, the measurements on residual bisphenols in leather are already ongoing. And so it is quite clear that non-transparency from the side of a chemical supplier will be detected quite easily. So that is one very old chemical that has come to the surface very recently and where the discussion is ongoing. The other chemical I want to talk about is one that is known to everybody and has a direct use in the leather manufacturing industry, and that is glutaraldehyde. Why is that called glutaraldehyde? Why? Well, of course, because on two ends it has the reactive group of an aldehyde, and on the other side the link between is a carbon 5, and that in biological naming is glutar. So we end up with glutaraldehyde. Many of you will have seen that in a tannery or in your own portfolio. And we know that pure glutaraldehyde is a substance with a substantial hazard potential. It shows the acute toxicity and corrosiveness of a typical aldehyde type substance. It is a sensitizer by inhalation and skin contact, but it has no other chronic effects. It has been extensively investigated and demonstrated that glutaraldehyde is not cancerogenic, not mutagenic, not reprotoxic. And so all the toxicity, all the hazards of glutaraldehyde, they can be properly controlled when it is used. And there are legal limits for glutaraldehyde at the workplace in place practically all over the world. They differ a little bit between the countries, but you can see that the most common one is a workplace threshold of 0.2 milligram per meters cube. And what is important to know in this respect is that the smell, the odor threshold of glutaraldehyde is lower by 2 orders of magnitude. And so there is a simple rule: if you don't smell it, you don't have a hazardous concentration. And that makes it easy to handle with glutaraldehyde because you don't need very complicated measurement installations to make sure that you're treating it properly, that you're protecting your people properly. And if you do measurements like TFL has done, like tanners are doing, it is easy to demonstrate that a residual concentration at the workplace is below any hazard threshold. What does glutaraldehyde do? Well, it's tanning leather, and it does so by reacting with the nitrogen groups in the leather, in the collagen, and then not just forming a direct link, but it can react with itself and with other groups. And so it is very versatile and can adjust to the distance of the nitrogen groups in the collagen. And that makes it a very good and a softening tanning agent. And if you see a typical offer would be 4% of a 50% solution. If you look at the content in the float, it is something like 16,000 ppm. Then already at a low pH, most of that is exhausted. If you increase the pH for fixation, the exhaustion goes up to 98, 99%. And then adding a little bit of a scavenger to eat away the last of the aldehyde makes it possible to have wet white, wet blue with a residue of only a couple of ppm. And on the crust itself, after drying, it's impossible to detect any glutaraldehyde. And contrary to formaldehyde, glutaraldehyde cannot be hydrolyzed, so it cannot be reformed. That makes glutaraldehyde a very safe tanning agent. But nevertheless, the authorities have decided to throw a couple of regulations behind it. And the first thing was that the authorities decided to list glutaraldehyde as an SVHC candidate in July this year, because it is an inhalation sensitizer. And that means SVHC candidate, they want to protect the consumers from glutaraldehyde exposure. And that means if you're importing an article into the EU, or if you're manufacturing an article that exceeds 1,000 milligram per kilogram, then you have to notify the authorities. But as we have just seen from the application table, the residue in the leather usually is below 5 milligrams, so it's far away from the level where you would need to notify anybody. And because there is no widespread use in the public, a prioritization for authorization itself is highly unlikely. Instead of that, the authorities have included glutaraldehyde in the master list for the upcoming restriction on skin sensitizers in textile and leather. And there is a threshold planned for this restriction and for sensitizers that is in the same order of magnitude as we already have for free formaldehyde with the most brands. So that may be somewhere between 20 and 100 ppm. Discussion is still ongoing, but as you just have seen, like for formaldehyde, the residual concentration of glutaraldehyde in the leather is lower than that. And so the restriction on sensitizers should have no practical impact if the tannery who is using glutaraldehyde for pre-tanning agent knows what they're doing. Again, the restriction is planned to be finalized in 2022, and the draft, as we know it, gives a transition threshold of 2025 for its coming into place. There will not be an impact, or there will not be a foreseeable impact on glutaraldehyde, but there may be an impact on other substances that are skin sensitizers, especially the textile industry is hit by having a lot of dyestuffs that are sensitizers. And in the leather industry, for example, epoxy-based substances will get into the focus because epoxy resins are strong sensitizers as well. To demonstrate that there is no risk, TfL and others in the past have already done epicutaneous tests on volunteers. So leathers that have been pre-tanned with glutaraldehyde have been taken and patched to the skin of volunteers. Usually in those cases, you're taking people or you're asking people that already have an allergy problem because it makes the test more sensitive. And in our case, we have seen that none of the samples had any negative impact to any of the volunteers who did that test. So it can be demonstrated quite conclusively that a properly tanned leather with glutaraldehyde is without risk for allergies. At that point, I want to summarize my presentation, and the first part was on the bisphenol type chemicals, which are the focus of some developing regulations, mainly because of their property as a low potency reprotoxin. And in leather industry, that means that bisphenol F can be an impurity in synthetic tannins, while bisphenol S is a monomer for the same group of chemicals. And so that can lead to residues in the products and in the final leather. And we're not yet quite clear what the scope and the impact of the regulation will be. Continue to watch it. It will come into force not before 2025, but it may be that there's a lot to do before. Glutaraldehyde is a pre-tanning agent in leather industry that has been proven safe and efficient in the last 3 decades. And there is no ban from the new restrictions on the use of glutaraldehyde as a tanning agent in a tannery. There is only restrictions to use it properly to make sure that there are no residues in the leather, and with state-of-the-art technology that can be well done. And that will show that chrome-free pre-tanned leathers with glutaraldehyde are a skin-friendly material where we can continue using it for the European and the global market as well. Okay, with those words, I've come to the end of my presentation. I hope also it was very theoretical. It was not too boring for you. And I'd like to thank you for your attention and hand back to the chair.
Thank you so much, Dr. Martin Kleben. It was a really, really nice presentation. Don't worry, it was not boring at all. I'm sure that all the tanners around the table here are very interested, and I'm sure that you will get a lot of questions because it's so important for our industry to keep such a material like bisphenol to make syntans and of course glutaraldehyde to make chrome-free leather and so on. So thanks again. It was really very clear presentation. Thank you so much, Doctor.
You're welcome.
Well, so we are on time, and now the next presentation is again from Brazil, our friend from Brazil. So the presenter is Dr. Agustini Caroline. So, Doctor, are you online? Are you with us?
Yes, I'm here.
Okay. So good morning.
Good morning.
What time is it now in Brazil?
To me, it's good morning. To it's 3 a.m. in here.
All right. Okay. Thank you so much to be with us. So I have a bio. So you are from Brazil, postdoctoral researcher at the Federal University of Rio Grande do Sul. You hold a degree in chemical engineering from the Federal University of Rio Grande do Sul and a master's and a PhD in chemical engineering from the graduated program in chemical engineering. You have experience in the field of chemical engineering with emphasis on biogas production, clean technologies, solid wastewater, biological treatments, and atmospheric emissions analysis. You are also the winner of the 2020 Professor Mike Redwood Sustainability Grant. So the floor is yours, so please.
Okay, thank you. So hello, everyone. It's an honor to present at the Youth Congress. My name is Caroline Borges Agustini. I'm a postdoctoral researcher in Federal University of Rio Grande do Sul, and I will present my work, Hydrocarbons and Carbohydrates Release during the Biodegradation of Solid Waste from Tanneries for Biogas Production. This work was developed in Federal University of Rio Grande do Sul in Brazil in Chemical Engineering Postgraduate Program in the Laboratory of For Leather and Environmental Studies, LACOE, under the guidance of Professor Marilis Guterres. It had the honor of being awarded with Professor Mike Redwood Young Leather Scientist Grant 2021 Sustainability Environmental Award. So a brief summary of the work, the investigation of how environmental parameters function during anaerobic digestion is an important step in improving the efficiency and process stability. This paper provides mainly the evolution of how the hydrocarbons and the carbohydrates release in order to improve the initial limiting step. Leather shavings and tannery sludge were considered in this study as the waste. And the main findings suggest that the anaerobic digestion of tannery solid waste can be separated into 3 phases. First, a long lag phase. Second, a log phase with a low metabolic rate. And third, a final phase where all the shavings were metabolized. Starting in the introduction of the topic, anaerobic digestion of organic waste, such as leather waste, is a method of producing renewable energy, such as biogas, with simultaneous waste treatment. Biogas is attracting significant attention as an increasing interest in renewable energy and sustainable energy technology, and it has the advantage of not having geographical limitations. However, many biogas plants operate at suboptimal loading rates to ensure a stable process at the expense of the digester productivity. There are issues during anaerobic digestion, such as process instability, long lag times, low biogas yield, and low methane concentrations. Some of our previous researches were focused on studying the feasibility of the anaerobic digestion of the mixtures of shavings and sludge in cold digestion process. Assessment of a semi-pilot scale procedure was studied. In this condition, study in a semi-pilot scale, a mid-sized tannery could reduce 6.8% of electric energy and 1.6% of thermal energy consumption, besides the great cost saving of disposal of this waste. And in a high throughput sequencing study, the highest amount of biomethane observed was related to the archaea family Methanocetacea and bacterial family Bacteroides. So the aim of this study was to evaluate the evolution of the hydrocarbon and carbohydrates release, the energy efficiency, and the efficiency of the treatment of the waste of the anaerobic digestion of the solid waste of tannery. The originality of this study is gaining the innovation of how chemical, physical, and environmental parameters work. It is an important step in improving the efficiency of the process and the process instability of anaerobic digesters to be able to adjust in which step of the batch process the continuous process must be designed, and which pretreatments could be used are most suitable to increase the carbon depletion of the waste. I'm sorry. So the material and method used, 22 identical and independent replicates of the batch co-digestion of the tannery waste were made. As the analysis that we performed were destructive and required a large volume of sample, every 10 days, one duplicate of the 22 bioreactors was opened for collection of the liquid and the precipitate. For every of this sample collected every 10 days, the biogas volume and composition was measured, and the solid and liquid waste, the hydrocarbons and carbohydrates release were measured with near spectra. The organic matter regarding treatment efficiency was monitored mainly to organic carbon and biological oxygen demand, and also chromium and pH analysis were performed. So the main results and discussion: the assays produced on average 28 milliliters of cumulative biogas per gram of volatile solid added, with a maximum percentage of methane of 63.7%. The greater the lag phase, the greater the recalcitrance of the substrate. So the lag phase of these tests were very long, approximately 20 days. Showing that the recalcitrance and complexity of the tannery waste caused the hydrolysis phase to take longer to complete. The log phase is regarded as a period of complete adaptation and high availability of substrate without microbial competition, and the higher the biogas production rate during the log phase, the greater the bioavailability of the residue. So the log phase began at day 20 of incubation and ended on day 95, and also it did not have a large slope, again due to the complexity of the residue, so that the biomass could not quickly metabolize the tannery waste. So here there is the visual representation of the assays throughout the process and as along the days. There are three different distinct phases of the process. Up to day 30, the shavings here are practically intact, so that the microorganisms are adapting to the waste and the hydrolysis has not yet fully completed. From day 40 to day 70, there is a great degradation, but however, some blue spots are still able to be seen from the shavings. And from the day 80 until the end, it's no longer possible to visualize the shavings, so that they were completely metabolized by the microorganisms. So the hydrocarbons and carbohydrates percentage calculated using F-10-year spectrometry concurs very well with the actual percentage of hydrocarbons and carbohydrates and the total concentration of this. They are relatively similar, the concentration and the percentage during F-10-year. The concentration of hydrocarbons and carbohydrates released in the medium have the highest concentration in the first phase of the process until 20 days, with a maximum percentage of 27% on day 20. This is due to the initial solubilization of the residues attributed to the hydrolysis and disintegration of macromolecules biopolymers to soluble monomers. In the second phase, the process between 20 and 70 days, the percentage of hydrocarbons and carbohydrates gradually decreases, reaching a minimum value of 21% in 70 days as the log phase of the process is established. In the third and final phase of the process, the percentage of hydrocarbons and carbohydrates rises to an intermediate value of 24% in 90 days. This can be explained by the total metabolization of the residues depleting the medium nutrients and causing cell lysis that releases unmetabolized monomers back into the medium, increasing a little bit the concentration. So the biological oxygen demand, the BOD, reflects all the available organic matter present for the microorganisms, and the total organic carbon, the TOC, showed a strongly similar behavior to BOD along the assays. Although they exhibit very similar behavior, BOD and TOC have two major differences. First, the concentration of BOD is much greater than the concentration of TOC throughout the process, since while the TOC represents only the carbon, the BOD represents the sum of all organic matter, all organic components that there are in the medium. And the second major difference is while the BOD showed a reduction of only 20%, the TOC showed a reduction of more than 60%. And as it leaks a lot of carbon in the form of biogas, methane and carbon dioxide, and the other organic compounds remain in the middle in the cell biomass, so the BOD is not so greatly reduced. Okay, the reduction of the denaturation temperature throughout the process is shown in the figure. Initially, the residue, here only the shavings, had a high denaturation temperature of 106 degrees Celsius, characteristic of tanning waste due to the presence of chromium, which stabilized the residue. And from the 10th day, and here we see the denaturation temperature of the mixture of the shavings, the sludge, it has dropped sharply to 63%, 63 degrees, and slowly reduced throughout the process, reaching 53 degrees in the 70th day. From the 80th day, the residue was completely denatured with no denaturation peaks. The concentration of chromium present in the assays comes from the processing of the leather, where in both residues chromium salts were used. The concentration of chromium throughout the experiment is as shown in the picture. Despite the great amount of chromium used in the tanning process, the tanning of the hides, little amount of chromium is diluted in the reaction medium because chromium has a very strong interaction with the hide still present. The initial concentration of chromium of 3.7 milligrams per liter is well below the limiting concentration for microorganisms of 100 milligrams per liter, and it was gradually increased throughout the process and reaching 45 milligrams per liter at the end. At day 80, there is a jump in the concentration, and this jump may be due to the degradation of the shavings, which can be seen, we saw visually that they degraded, which have, so that all the chromium that was attached to the shavings were diluted in the reaction medium. So in conclusions, the results show that the anaerobic digestion of ternary solid waste can be separated into these three phases. First, a long lag phase of 20 days where the microorganisms slowly adapt to the waste due to its high recalcitrance. The hydrocarbons and carbohydrates reach their maximum at this phase of 27% due to the waste solubilization and the first hydrolytic action. Second, a log phase with a low metabolic rate of 15 milliliters per day due to the complexity of the waste, where much of the chromium present is bound or adsorbed to the shavings, not inhibiting at all the process, and hydrocarbons and carbohydrates reach their minimum percentage of 21%, since the metabolic action of anaerobic digestion is fully established. And the third, the final phase, where all the shavings were metabolized and all the chromium dissolves in the reaction medium. With the depletion of the nutrients, the cell lysis also occur. So there is a releasing of hydrocarbons and carbohydrates back into the medium, reaching a final intermediary value of 24%. So these are the main references. And I would like to thank IULTCS for the honor of receiving Professor Mike Redwood Young Leader Scientist Grant 2021 Sustainability Environmental Award, the Federal University of Rio Grande do Sul, and my dear colleagues from Lakota. Thank you for your attention.
Thank you very much, Dr. Agostini. It was a very nice presentation and very, very interesting. So I'm sure that also we get a lot of questions at the end of the session.
Yep.
Muito obrigado. So the next presentation is from Italy. Dr. Claudia Florio, are you with us?
Yes.
Okay, so we can see your presentation. So thank you so much, Dr. Claudia Florio from Italy. So let me read briefly your bio. So you are a scientific coordinator of Station Experimentale Industrie Peli in Italia, a leather research institute. You also serve as a scientific manager at Tanningat Biotechnology Research Department of the institute. Dr. Florio is also handling different courses in different universities like Mercatorum University, University of Roma, and University of Campania as guest lecturer. So, Doctor, the floor is yours. Thank you.
Thank you. Thank you very much. And good morning to everyone. Well, the topic I'm about to discuss will concern new frontiers of advanced diagnostic and non-destructive testing for quality control in the tanning industry. And so, in spite of the growing use of alternative materials such as plastic-based ones, currently leather is still one of the leading materials in fashion and luxury market due to its excellent quality features. And it is also the reason why it is absolutely necessary to prevent any occurrence of defects, especially considering the growing diffusion of even novel tanning technologies that sometimes make some defects unpredictable, and where early advanced diagnostic techniques may avoid possible negative repercussions for producers and allow to plan innovative solutions in order to guarantee product quality. So the aim of this work is to describe how some specific instrumental techniques are able to provide information concerning possible causes of the defects and also revealing the specific phase of the tanning process potentially responsible for critical issues. And moreover, other non-destructive testing systems have been considered for their use in quality control of tanning production in order to guarantee even more increasingly predictive and non-destructive approaches and solutions. So 90 cases of defects were analyzed, where each case concerned leather and leather articles from different origin and for different intended use as furniture, automotive, footwear, clothing, leather goods. Well, where these samples have been identified over the years as a result of support activity to tanning companies. Concerning methods, the samples were analyzed with the following instruments, with particular reference to total reflection, infrared spectrometry, optical and phase contrast microscopy, Scanning electron microscopy, also equipped with X-ray probe for microanalysis of the surface, differential scanning calorimetry and thermogravimetric analysis, and then gas chromatographic mass spectrometry, also equipped with autosampler for VOC analysis. And furthermore, we considered other novel non-destructive testing with particular reference to electronic speckle pattern interferometry in some feasibility studies. So let's have an overview of the results obtained and of the role played by each of these techniques. And so in this table, you can see that the case investigated were chosen as representative as possible of all the main categories of defects found in LiDAR. And the table shows that the type of defects found in their incidence by category of article and their overall impact. So you can see that we found mainly defects caused by stains, different kind of stains, as stains from metals, stains from organic substances, from soaps, from saline and fatty repos, from microbial attack. And then we found the diffuser chromatic alterations as yellow and pinking of the surface, and moreover, lack of dye homogeneity inside the LiDAR section, as well as detachment of finishing, morphological defects, cracks in the finishing, and finally, low mechanical resistance all the wall of the interior LiDAR structure. And concerning the techniques, as you can see in this slide and in this table, we found that the resolution of individual cases required the simultaneous use of more than a diagnostic technique, even if some of these have proved to be decisive and crucial for the characterizing of specific critical issues. So let's have an overview of the role played by each of these techniques. Particularly, alternate total reflection infrared spectroscopy was proved to be a very crucial technique. Is a non-destructive method. It was mainly used to solve problems related to finishing. In relation to its critical issues related to mechanical, chemical, and physical finishing fragility. For example, in this picture, you can see the overlap of two spectroscopic profiles of damaged finished nitrocellulose base, which was proved to be more sensitive to the action of organic polar solvents, okay, when compared to non-defected finish that in this case was based on polyurethanes. In other terms, this technique was proved to be very performing in order to have a fine characterization of the chemical nature of finishing, also when this information was not available for producers and later users. And then the technique was also effectively used to study the effects of surface yellowing, and when related to the massive use, for example, of aromatic polyurethanes in finishing. And then optical stereomicroscopy was proved to be mainly effective for or preliminary surface analysis in order to have some initial clues on the possible origin of defects, while phase contrast microscopy was proved to be very decisive for investigating the possible causes of mechanical structural finishing defects to the examination of LiDAR section. And through the examination of LiDAR section, it was also possible to have clues on the errors in the wet phases. For example, if you have information on residues of hair, as well as residues of blood and so on. And then some morphological analysis allowed investigation mainly of crystalline amorphous morphological features of deposits, suggesting their possible nature. And then SEM analysis was also crucial for the study of defects caused by microorganisms, with the possibility of distinguish between the kind of microorganisms, for example, with the possibility of distinguish between the genus of molds found on LiDAR. Then microanalysis was found to be one of the most effective technique used in LiDAR diagnosis of defects, with particular reference to the study of possible origin of defects caused by metals, where metal-based defects resulted to be very diffused in later cases examined, and where, when involved in later defects formation, metals can cause two main kind of defects. Colored spots on the surface, sometimes in combination with some deposits, and the wall non-homogeneity in dye distribution, both on the surface or among the cross-section. Then the thermal analysis was proved to be effective for both studying defects related to possible critical uses of finishing and defects related to structural components of laders, such as collagen or fats and so on. Concerning finishing, the knowledge of parameters as the degree of crystallinity, the determination of glass and transition of polymers, and so on, is really a crucial tool for the comparative studies of finishing and for the design of improved and innovative solutions for finishing. And moreover, this diagnostic approach has been also proved to be potentially strategic for comparative characterization of possible defects related to the thermal resistance of laser processed with different kinds of tanning agents. For example, for the comparison between the thermal resistance of chrome and chrome-free tanned lasers. And finally, gas chromatography mass spectroscopy was proved to be effective in case of defect caused by organic substances, such as organic pigments, fatty substances, or other organic substances as antioxidants, plasticizers, biocides, that was involved in later defects through more complex mechanisms. And when combined with the autosampler for VOC analysis, it's moreover allowed to identify two main classes of compounds capable to providing special clues to the origins of specific critical uses. For example, aldehydes, ketone, furans, and so on can provide some indication on the state of degradation of organic components of leather, such as fats, in order to clarify the possible contribution of more indirect thermoclimatic aging conditions on the onset of the defects, as well as solvents deriving from leather, such as from assembly materials, can provide special clues on the defects deriving from degradation of some components of finishings that are sensitive to the action of these solvents. But we also consider the use of novel non-destructive testing technologies, with particular reference to the electric spark pattern interferometer. That is a phenomenon based on the coherence of the light, which when striking a raw surface makes a random phase jump without losing its coherence. And this generates an interference effect that can be constructive or destructive, resulting in an image composed by dark and bright dots. So the digital comparison of different speckles leads to the creation of an image showing a series of overlapped fringes on the screen of the surface being examined. So in this example, you can see on the left the surface of a defected leather, where some cuts are present but are only barely visible on leather surface, while on the left you can see the leather surface processed by these techniques, where the cuts have been highlighted with the possibility of having predictive solutions and to avoid the worsening of defects. Then we considered also computer vision techniques that are based on scanning and processing signals and image at different wavelengths from visible to infrared. And so you can have a tool that works with the similar functions as human vision. And this tool can use cameras based on sensor, which can be linear besides time frame. But the interesting thing is that when coupled to robotic systems, this technique make possible the acquisition of processing operation in an inline mode, so that you can have a check, a control of the production during the production process. And this is really very interesting. And Finally, at the software level, the advent of deep learning techniques that are family of artificial intelligence models were particularly active for image analysis with a new approach based on artificial data-driven neural networks, thanks to ability of those models to learn from data autonomously, which are the best features to extract. In other terms, algorithms are able to generalize what they have learned and thus recognize and characterize defects even when required to process new image that were never seen in the training phase. And it is really, really interesting for a later examination, considering its intrinsic variability and the natural origin of data. So in conclusion, advanced diagnostic techniques allow to identify errors in the critical issues deriving from specific phase of the tuning production in order to plan improvement action and design more efficient and innovative solution to guarantee product quality. And furthermore, the increasing use of non-destructive techniques and tests and automated approach, as well as artificial intelligence approach, deep learning approach, allow to have further preventive and predictive approach and solution. And so definitely all these techniques was proved to be really efficient in order to guarantee the quality control of the new generation of leather production and leather articles for the benefit of the whole supply chain. So thank you for your attention.
Thank you very much, Dr. Florio. It was a very interesting presentation about the NDT techniques. So I'm sure that also for this presentation, many questions will come. Well, I don't know whether we have Mr. Chen now online for his presentation on salt and chrome-free leather making technology.
I'm afraid not.
No information, no news about him?
No.
No?
No, unfortunately.
Well, so it seems that he's not online. Okay, so I'll take this opportunity to say hello to Professor Muni Ikyone, who is in line. We are very happy to see you, Professor. We appreciate it very much. Thank you so much. Well, so if we don't have Mr. Chen Yongbo, maybe we could proceed to the question and answers. Yeah, okay. So, Jeff, you are online. So, can you manage for the questions?
Yeah, I do have I have sight of them, but I'm hoping that the IT group, here we go. They've already taken control. So, yeah, first up, we have a question from Dr. Michael Mayer to Martin Klaben on: do we know which polymetric structures are generated from glutaraldehyde and to which content? Or which content or extent? I don't know. But yeah, Martin, are you able to answer that one?
Well, to a certain extent, we have some ideas from analytical evidence, but I'd like to hand Michael here to my specialists, my colleagues in the R&D department at TfL, and I think that will be a longer discussion, and we'll probably take it up separately.
Yeah, it's very technical, isn't it? Of course. So that's a great suggestion. Thank you very much for that. So the next question is for Caroline, I believe. Yeah. Yeah, so we're just inquiring, Dr. Agostino, on whether you could confirm that chrome tan shavings are completely degradable, but only on a long time scale. Do you use the anaerobic sludge several, sorry, and question 2, do you use anaerobic sludge several times? And if yes, did you observe that the lag times became shorter? That's also from Dr. Meyer, Michael Mayer, sorry. Would you like to answer either of those or both of those questions?
Yes, I can answer both of them.
Excellent.
Can you hear me? Okay.
Yes.
Okay. So thank you for the question, Dr. Meyer. The first question, would you like to confirm that chromium and shavings are completely degraded? Yes, not only on a long time scale, but there is the possibility that in this particular study we did not use. There is pretreatment techniques such as thermo, enzymatic, many other pretreatment we could make that for sure would short the long time scale. I was looking at our previous studies, and we could regarding the second question, that the lag time could reduce to by the half to 10 days just if you did a thermal pretreatment. So the pretreatments in this study we did not use to thinking further for easier implementation in a tannery, that there is any other phase, just the digester. So, but of course that we can short this time. And regarding the sludge, there is a high heterogeneity of the sludge, even in the same assay with the same sludge. There is different times, the different time that the tests end, because there is this. And also I've observed short lag times when we did thermal pretreatment. So I believe that the secret to make a short time of the experiment is the pretreatment. But there is of course a cost analysis that can say if the pretreatment is economic viable, if it's worth it to do it even with a shorter time.
Excellent, thank you. Yeah, that's really good. I would also second that. Actually, in our own little studies, we've seen that breakdown times for chrome tanned shavings can be very short indeed. Nothing like the scale that we've seen if you've got a hot temperature or high temperature. So yeah, excellent. That's great.
Also the temperature of the assays, not mesophilic, but thermophilic, for example.
Yep, yeah, exactly. Perfect. Okay, thank you for that. And the next question is for Dr. Florio, I believe. Oh, Dr. Tigmeyer, sorry, apologize. Yeah, so this is to Martin, of course. Can you comment on the availability of glutadialdehyde as the tanning agent as compared to chromium-3 sulfate in lesser developed countries globally? That's from Michael Karaya. I guess the point is that chrome is very universally available in large quantities, whereas glutadialdehyde may be a little bit more specialized. But could you comment on that one, please, Martin?
I would say if we're talking about a normal consumption level as it is right now, there should not be an issue to have glutadialdehyde available anywhere on the planet. It's a well-known chemical, it's registered, and there are various preparations ranging from the highest concentration of 50% down to 14%, sometimes masked chemicals. So if the workplace safety installation is not as advanced as it is in Europe or the US, there are other formulations that can help support the tannery in handling the chemicals safely. So for the moment and for the quantity that is necessary at the moment, the supply situation is, to me, comparable to chromium-3 sulfate. Whatever you can call comparable today, because we've seen shortages of all sorts of chemicals and raw materials at the moment because of the very disruptive supply chain situation we have after Corona. And that can actually mean that it's hard to get some chemicals in some region, but that is not to the availability from the production side, but more an issue of the supply chain currently. And I'm afraid that many of you have seen that recently. And of course, industry is working hard to get that straightened out, but it's really a mess at the moment.
Yeah, I agree. Even basic chemicals. Okay, next question. So this is Dr. Florio. There are 2 DSC profiles with the onset temperature of approximately 200 degrees Celsius. These are very high values, and I wonder to what they are related. Could you please explain a bit more? And that's from Ramakrishnan Prasad Mupa. Dr. Florio?
Yes, can you hear me?
Yes.
Yes, in the slide that I showed, that was just an example, and it was related to a particular case of the examination of comparative studies between 2 polymers, nitrocellulose based. So it was not referred to collagen structure. So I think this can answer the question.
Yeah. Okay, thank you. That's good. Next question, please. Again, I think your talk was incredibly interesting, by the way. And so does Yanan Wang, and he's inquired, thank you for your presentation. I'm interested in the NDT tech. I'd like to ask for the scale length magnitude of the leather image you showed.
Thank you for your interest. That was just a feasibility study, so we are going to test many magnitude, and so if you want, we can keep in touch, and then I can share particular cases with different magnitude.
Thank you. And to Dr. Agostini, again, a very interesting presentation. Can you clearly show how carbohydrates can be released from the chemistry of the tanning reaction systems? From Michael Karaya again.
Okay, can you hear me?
Yes.
Thank you for the question. Yes, the carbohydrates and the hydrocarbons were a limitation of the technique we utilize. Of course, if we were, we would see a much greater proteins regarding the collagen degradation, initial degradation. So the carbohydrates, we use them, we measure them to see regarding the hydrolysis, not the concentration, but the variation of the concentration. And the carbohydrates can be released from the tanning of the chemistry of the tanning, from the leather, from the sludge, the cleaning of the process, all the sludge, that was taken from the leather, and also from the other nutrient supplies that in the anaerobic digestion need to be added.
Okay, well, thank you. I think that's all the questions we have. I would just like to inquire of Dr. Hansen whether he feels that the 24% reduction in chemical usage, which was shown in the work in his presentation, was an indication of the fact that in the leather industry we often struggle to define the uptake and efficiency of the processing, or is there an opportunity for us to reduce chemicals and still produce the same leather? Is that the message exactly that you're presenting?
Oh, so the point that we were testing is, first of all, we tried different reduction percentages based on previous studies published in the literature. There are some studies already made in laboratory scale, but we find that mainly because of the differences between pilot and laboratory scale and industry scale results, most of these studies, or many of them, are not applied in industrial scale yet. So what we did was to try different reduction percentages in industrial scale to find out if the leather obtained was within the established standards. So yes, in the conclusions, we found that this could be done in some more tanneries since they go through the steps doing the tests in pilot scale and also in industrial scale to test if there is an opportunity to reduce the offer of chemicals in the formulation.
It's going to become very important, of course, to ensure,
So
you know.
we have a question from Dr. Rajamani, oral question.
Yes.
Doctor, please go ahead.
Good morning. This is the question to Dr. Agustin. You have done an excellent study, particularly anaerobic digestion of the shavings and the sludge. Under what pH you fed the sludge, the combined feed to the reactor? What is the average pH?
Oh, pH. Yes, we measured the pH. I just did not show it on the presentation. Its average, it remains at 7, but there is a high problem measuring the pH because the CO2, the carbon dioxide there is in the medium, it's very important to control the pH. So when we do measure the pH, we open the reactor and the carbon dioxide, the pH quickly neutralized. So
Then another question: have you measured the sulfate content? The sulfate. Also,
no,
is
but
there any reduction in the sulfate at the end? Is there
yes,
any change in the sulfate?
Yes, we have the chromatograph. We aim to measure the sulfate in the gas, but we observe the sulfate when we have some tests that did not proceed because they turn out the whole residue become black because of the sulfate formation. But we did not actually measure the sulfate, but it is our aim.
That's good. Why I'm telling is, if the real anaerobic is working, means whatever feed you give in the form of sulfate, it will start reducing at the end. The sulfate will likely to change into sulfide. That's why that is one of the important indicator. Sulfate reduction is a good anaerobic digestion.
Yes, of course.
Problem may be more sulfate, then you will have a problem of sulfide conversion.
Yes.
It's good. It's a very good study, and hope it will have got a lot of future. Thank you.
Thank you. It's an honor to meet you.
Thank you very much. And any more questions? I don't think so. Thank you very much for everyone who's presented today. I feel that was a wonderful session. We can hand back to Ethiopia.
Thank you, Geoff. So if there is no more question, the session 4 is over. So we are, of course, right in advance on the timing. So now it's a coffee break. Professor, I give you the microphone. Please explain.
Thank you very much for our great moderators and also for the excellent papers presenters. We will have a small certificate handover for the presenters. I'm sure our IT unit is ready to display the certificates of presenters. I think it is displayed, the first presenter. Thank you very much. That's all. Thank you. We will break for tea. It's a bit, we are ahead of time, but as there is no one paper missing, we can go for, we can break for that. Thank you very much.
Okay.
During the break, we can still browse the posters on the poster session.